Here we've got a couple more problems where we're going to rationalize the denominator. And again, we're going to follow those same procedures, but we're going to do a little bit of simplifying first. So looking at 5 over the square root of 20, we could just start rationalizing the denominator. We sure could. But do you notice that the square root of 20 is not fully simplified? I think that it might be best for us to go ahead and simplify this first. So looking at 20, wouldn't 20 be the same thing as saying 4 times 5? And then we could take the square root of each one of those. So the square root of 4 is really 2. So if I were to rewrite this in a more simplified form, it would be 5 over 2 square roots of 5. Now we can finish rationalizing our denominator. What we really want is we would really like to have this be a perfect square underneath that radical, because this is a square root, so that it would undo each other. Our goal then is to figure out what do we have to multiply by to make it happen. So we have the 2. We need another square root of 5, don't we? Because the square root of 5 times the square root of 5 is the square root of 5 squared. And again, we can do that as long as we do it to the top, so that we're technically just multiplying by 1. Okay, so 5 times the square root of 5 on top would be 5 square roots of 5. Okay, now I'm going to come down here and simplify some more. So on the numerator we have 5 square roots of 5. And in the denominator we have 2 times, well, our square root and our square undo each other, so that would just be a 2 times 5. And now looking at this, we can simplify some more because we have a common factor on top and bottom. So our final simplified and rationalized answer here is the square root of 5 over 2. Now, if you didn't see to do this first, you absolutely could have rationalized as is. You would have just had to done a little bit more simplifying at the end. Okay, now looking at this problem, square root of 2 over the square root of 6. Do you remember that we had that rule that said if we've got same index roots on top and bottom, we could rewrite that as one gigantic root? Remember doing that? Then by doing that, we can now simplify. And the reason that I saw that was because 2 over 6, I know, will simplify to something a little bit better. That actually will simplify to the square root of 1/3. And now we can always break it back apart. This would be the square root of 1 over the square root of 3, which is, the square root of 1 is 1. We can't do anything with the square root of 3. Now we're to a point where we need to rationalize our denominator because we can't leave our answer like this. So what we really, really want is on the denominator, we would like to have the square root of 3 actually squared so that those would cancel out. So what do we have to multiply by to make that happen? We'd have to multiply top and bottom by square root of 3. Remember, so that we're just multiplying by that 1. So now on top we have 1 times the square root of 3, which is the square root of 3. And then continuing to simplify, we'll just do one step at a time and let that lead you to the next one. On top we have the square root of 3. And on bottom, the square and the square root cancel each other out, so we just have a 3. So our final answer here is the square root of 3 over 3.